Hello, everyone. Today, I'm going to present my project, which is an income classification predictive model. Um, the objective of this is to predict whether an individual income is greater than or less than 50K per year. I'm going to use a different provided algorithm which actually predict where with individual income. Some content that I'm going to talk about is I'm going to talk about some overview of projects, methodology, diagram, result, and then finally conclusion. In the last 2 decades, society has grown a great deal of reliance on information and data. Data mining and machine learning has been highly utilized in discovering and exploring several previously unknown patterns and concepts of data analysis. Aspects such as prediction of futures events have just been made easy and possible, which were initially challenging to execute. Income inequality has for long been a key issue whose sustainable solution is only possible through the new data analysis technique. This study is therefore anchored on analyzing the data census income dataset and coming up with a model that predicts whether a person income exceeds 50K per year as provided in the dataset. The dataset was again from USCL machine learning respiratory site. That's where I got it. And the data was obtained from USCL machine learning respiratory site, as I said before, and was stored in three files, namely adult data, which is a training set, adult name, which is the data set description, and adult test, which is the testing set. And the data comprises of anonymous and detailed information such as age, income, occupation, education, working class of individuals. These features correlate strongly with individual income and potentially and will be used altogether to build an accurate and consistent model. Methodology. It comprises of 48,790 instances and 50 attributes for the dataset. This dataset contains both categorical and numerical attributes. And the next slide will be the detailed description of the variable of study. Here on the left side, we'll see here, on the left side, there's a name, and on the right, there's a description of it. So age is the age of individual, and working class is the type of an employer the individual has, whether it's government, military, private, and so on. And this is a sample weight. This is a number of people, but I was not using this because this might not be my target variable, the income. Education is the highest level of education achieved for the individual. Martial status is the martial status of individual. Occupation is the occupation of individual. Relationship, it's wife, own child, husband, not in family or as a relative or unmarried. Race is white, Asian, black, and so on. Gender, female, male. Capital gain is capital gain. And then finally income, which is like whether the person makes more than 50,000 annual. And then loading the data. I start by loading the data set from USCL machine learning respiratory site. I need to assign the column name manually since the train and testing dataset doesn't come with the column name by default. I also has to pass a regress to the separate parameter to the pandas CSIT function by using a separator symbol this comma. We're going to opt here data exploration from here, which you all see here on the graph. This outlines the relationship between the income and the type of occupation from the population study. You see the red line, which is represent income less than, and the blue represents income greater than. From here, we can observe that the executive managerial and the professional specialty um, makes more than 50, and the rest we can see it's less. We can explain more on here. So say the graphs that outline the relationship between income and the type of patient from the study population, and the red bar represents a segment of the population that earns an income less than 50K, while the blue bar represents the population with an income greater than 50K. It can be observed that the majority of the sample population across all occupations receive an income less than 50, as we see on the graph. And the executive manager and the professional specialty are among the highest paying professions, since they are the largest proportion of income greater than 50K population. So that means this blue line and the one, the professional specialty, that we can see it's more than the rest of the population. And army clerical, craft repair, other service, and cell occupation are among the profession with the lowest paying income. There's also another one, a little bit different here. This is the relationship between income and the working class. And the rate is still the same. People who earn less than 50, and the blue represents people making more than 50. Right? So we can see that the people working in the private and small more than the rest of the people here. So the bar graph shows that the outline ratio between income and the working class from the study population. The red bar represents a segment of the population that earns an income less than 50K, while the blue bar represents the population with an income greater than 50. It can be observed that the majority of the sample population are all the work bracket relatively receive an income less than 50K. The private work class is among the lowest paid cadre, since they have the largest proportion of income less than 50. The private and self-employed class, uh, the private and self-employed here, are among the profession with the highest paying income, with the majority of the population fairly in greater than 50 income category. So next will be the data pre-processing. So the data must be pre-processing, that might be cleaning and preparing of the data. So one of the process that I was using is that I used was building a missing value. So the missing value has been definitely dealt with for each attribute by setting a default marker called question mark, a symbol here. The dataset contains a certain arrangement of missing qualities for absolute highlight, world class, occupation, native country, which has been managed by dropping the missing value. Encoding of categorical values. We do this because the machine learning model only working on expect us working on the numerical value. So we need to transform the categorical to numeric form, so that will help us to build the model. So all attribute in any data set must be in numeric form for every machine learning model. And then shuffling. The whole data has constantly subjected to shuffling while ensuring that all categories of variables are encompassed in training set and validation set. And then splitting. The dataset has been split into training and testing sets. Training dataset takes 80% of the data, while the rest 20% is used for testing. And finally, what I have got here, from the aggregate of 48,790 features present in the dataset, 39,032 attributes have been utilized for training, while the rest 90,758 occurrence has been held for testing. The training accuracy depicts the exactness accomplished on the training set. From the model, a testing accuracy of 80%, 83% is accomplished on linear logistic classifier and 70% on the random forest classifier. And the validation accuracy depicts the precision accomplished on the validation offset. And finally, I'll get into conclusion. The paper proposed the use of machine learning with TensorFlow, linear classifier, or logistical regression, and random forest on other census data. After conducting the analysis, I obtained a testing accuracy of the model at 70% on random forest model. The linear classifier model or logistic regression was also deployed, which produced an elevated precision of 83%, which is relatively similar to other income prediction model up until this point. And thank you.
Any question? So what happened to the missing values? What did you do to it?
So what happens the missing values?
Yes.
So the missing value is something that you will put or remove from the data set, right? So there was a final with that. I was the final with that was not the target value from my income. So I did not use that on my in my module. So I removed that stuff, and also the education, which is the number of year from education level.
Any other question? Good. Next person, please.